All right, guys, so in this video, we are going to be covering multiplying polynomials. So our I can statement is for 1.1b. So Unit 1, Topic 1, Part B. Our I can statement is I can multiply polynomials. So in our last video, we covered adding and subtracting. In this video, we're going to cover multiplying. We won't cover dividing this year. That's actually something you do in Algebra 2. And just don't forget to put a date up in the top. I'm recording this on the 10th, but you will be watching this later next week. Okay, so to start, let's label this our notes section. But to start, I want to review something that you learned last year. And what it's called is the product of powers property. Mathematicians are not very creative. I say that all the time. And so they name things very straightforward. Product means multiplication, and powers are anything with an exponent. So this is when we multiply two bases together. And so an example we would have had would have been x to the fourth times x to the third. And we wanted to simplify this. X to the fourth means multiply x by itself 4 times. That is multiplying x to the third, or x times itself 3 times. So if we count it up, we have x being multiplied by itself a total of 7 times. So we get that by doing 4 plus 3, which is 7. So the rule states that when we multiply like bases, when we're multiplying like bases, so x and x are the same. If it was x to the fourth times y, this wouldn't work. When you multiply like bases, you're going to add the exponents. So again, this is something that you've learned last year, but it's going to be super important as we get into multiplying polynomials. So the first combination that we can have is if we do a monomial times a monomial. So remember, monomial means a single term. So if I were to multiply something like 7x to the 6th y by 2x to the third y to the fourth, when we multiply a monomial times a monomial, we want to multiply the like parts. So just a quick note, this is a monomial because there's no addition or subtraction. So this is all one term. Same here, no addition or subtraction, making it all one term. So here, we're going to multiply the like parts. 7 and 2 are like because they're coefficients, they're numbers. So 7 times 2 is 14. Then I'm going to multiply the x to the 6th by the x to the third using my power property rule. 6 plus 3 is 9. And then don't forget, this y secretly has an invisible 1 as its exponent. So y to the first and y to the fourth make y to the 5th power. And so that's our final answer. Let's do just one more. So let's do negative 3ab to the 7th times 4a to the third b squared. So again, let's multiply the like parts. Negative 3 times 4 is negative 12. A to the first times a to the third. We're going to add those together to get a to the fourth. And then b to the 7th and b to the 2nd makes a total of b to the 9th power. The next type we can have is if we have a single term, so a monomial, times a multi-term polynomial. And here we're going to use the distributive property. So for example, if I had 3x cubed times 2x to the fourth, that's a 4. Let's try writing that again. Plus 8x plus 1. We're going to go ahead and distribute the monomial to all 3 terms. So when I do the first one, 3x cubed times 2x to the fourth. 3 times 2 is 6. X to the third and x to the fourth, we add those together, we get x to the seventh. Then when we do the next one, 3x cubed times 8x. Remember, this really has a 1 as its exponent. 3 times 8, the coefficients multiply to be 24. And then third and first make x to the fourth. And then the last one, 3x cubed times 1, gives us 3x cubed. Let's try one more. So let's try negative 7x squared times 4x cubed minus 7x minus 3. So negative 7x squared times 4x cubed. Negative 7 times 4 is negative 28. X squared and x third, we add those powers, gives us x to the fifth. Now negative 7x squared is multiplying negative 7x. So a negative 7 times negative 7 is positive 49. Remember, the invisible 1 is there. So 2 plus 1 is 3. And then negative 7x squared times, again, because of the minus sign, negative 3, is going to be positive 21x squared. So then the last combination is if we do a multi-term polynomial times another polynomial. So two things with multiple terms. I'm going to show you two ways. So method 1 is called box method. And then method number 2 is using the distributive property. And I also sometimes call this mailman property, and I'll show you why in a moment. Mailman method. Okay, so let's do method 1 using 2x plus 3 times x minus 4. So box method, we're going to make, and you might have done this when you're in elementary school when you were learning to multiply. We're going to make a box, a 2 by 2, because I have two terms times two terms. So that's 2x plus 3, and then x minus 4. And so in this box, it also might make you think of science, like Punnett squares, when you're doing the genealogy stuff. If I do 2x times x, don't forget these both have a power of 1. That's going to give me 2x squared, 1 plus 1. Then if I do x times 3, that's going to give me 3x. And if I do 2x times negative 4, in this box, I'm going to get negative 8x. And then if I do 3 times negative 4, I'm going to get negative 12. So I'm going to add those all up, 2x squared plus 3x minus 8x minus 12. And then my last step is going to be to combine those like terms. So I get negative 5x as my middle term. And that's my final answer. So that's box method. The distributive property is going to require me to distribute both terms to the second polynomial. So 2x gets distributed to x. That gives me 2x squared, so 2x times x. Then when I do 2x times negative 4, I get negative 8x. The reason I call it mailman method is because 2x has to be delivered to the first term, and it has to be delivered to the second term. Same with 3. 3 needs to be delivered to the first term, so that's 3x. 3 needs to be delivered to the second term, that's negative 12. And so you can see right here, this thing I got in the box method is the same exact thing that I got using the distributive property, aka mailman method. And so we finish by combining like terms, and we get the same answer either way. So you get to pick which method you prefer for multiplying polynomials.